So my presentation today is entitled Anycast All the Things, and it's essentially, we're going to go down the journey I've gone down the last 8 years or so, experimenting with Anycast. So yes, my name is Theodore Baschak. I'm an IT consultant. I have extensive experience in networking and DNS. I've been involved in many layer 2 multi-vendor disasters. I've been an operator of DNS since about 1997. Might be 1996, but it was the 90s anyways. I've been operating ISP networks since about 2005 or so, and I've been operating my own BGP since 2016. I run the bgp.guru blog if you've ever run across that, although now that Google is auto-summarizing things, I think I'm like gone. And this presentation is going to bring together all these various things to talk about handling services on the routed network layer. So, what is Anycast? Well, you've probably heard of unicast before, maybe multicast. Anycast is defined in the RFC as the name given to the practice of making service addresses available to a routing system at Anycast nodes in 2 or more discrete locations. So I really abuse the 2 or more discrete locations. You know, discrete could be 2 different floors maybe even, but I've experimented with a lot of that. And it's used for performance, so scaling and load balancing, improving response times, keeping traffic local, geo-limiting DOS and DDoS attacks, and geo-distribution, hopefully getting services closer to the actual users of the services. So as I mentioned, it runs at the routing protocol layer. BGP is used most often, but the RFC doesn't require BGP. And I have experimented with using OSPF and other things, just to say I'd done it basically. So any routing protocol can be used. I haven't done it with RIP, but I have done it with OSPF. And the RFC specifically mentions both internal and global internet use cases. So I've done more on the internal use cases, but I've also messed around with a little bit on the global internet side. So my journey. So the very first experiments that I played with was I had 2 sites and it was OSPF, and the one site was my house and the other site was the colo location I have, and it was an HTTPS service, and I had a single v4 IP and a single v6 IP, and I could load a web page and it would say, oh, it's loading from home or it's loading from the colo, and that was the entirety of it, and I was like, yes, check. I could turn on or off things, I could health check things. It was great. So I was going to actually run my website that way for a while, and I thought, you know, that just makes my house too important. I don't want to have to like do work to keep my website up, so I never changed that part. So the next part after that was I experimented with BGP. So I moved to 3 sites. So I had the site that was at the colo still, and then I had a site that was in LA, and I had a site that was in Amsterdam. And I was using a provider called DevCapsule, and they are so gone now that I had trouble finding them. I couldn't find their old ASN. The internet changes. I actually couldn't even find the history of my own advertisements with them anymore, which was a little bit sad. So I know it was before 2018 that I did this, but I don't know exactly when I did this anymore, which I'd have to look in other locations, I guess, for the data. So the sites, or the services that I ran for this was an HTTPS service, and I ran some DNS services. The HTTPS services are easier to spin up quickly, and you know, you can spin up a web server and put a single page on it in like seconds, where delegating DNS and making things actually use it it takes a lot more work. So the HTTPS is a little bit easier to play with there. And in this case, I moved from doing IPv4. I took that out of the equation because I don't have enough IPv4 space to do this. Because once you start doing it on the global internet, you need to do a whole /24. And I wasn't like uprooting everything that I had to turn it all into Anycast and basically break it. So I moved to just doing it on IPv6. So I did 2/48s out of my /40 that I have. And it worked. It was interesting. I had to go through some, well, it's one of the first things that you run into once you start running Anycast on the internet is you try to balance your advertisements so that you actually can see all of your locations even. And DevCapsule was doing some strange things with their upstream, so they were prepending a different number of times depending on the location. And so basically I could only ever see the Amsterdam location. I could never see the LAX until I put a support ticket in with them, and I asked about like their global routing policies and is there communities I could use to influence these things. And they actually got back to me, which was impressive because sometimes I ask questions that completely stump tech support. And then the next experiment that I did after that was just 2 hypervisors in one rack. So again, 2 discrete locations I'm really abusing that definition there, but you know, if one of them went out, the other would have still been up, right? I've also experimented doing BGP Anycast on MikroTik routers, and I did that with DNS fairly successfully using the built-in DNS resolver. I was able to make several instances of that. And I also experimented with doing Radius that way using the MikroTik user manager, and that did not work out well at all. I'll get into that later when I talk about some of these specific OS peculiarities. And then now I have a couple different Anycast setups. The one is at my house, and it's in 2 different floors in the same building, like I said, so I'm really pushing that 2 discrete locations, but I run an Anycast recursor at home, 100.64.100.64, and it's highly available. It's been, it's on a Pi 3, a Pi 4, and a VM. And the reason I did that is because the VM is usually faster, but it takes a lot longer to boot up, and I have to press F1 because I don't have real Dell memory in that system. And so I don't want to have my DNS not boot up, and so I put it on a Pi so that at least it's there. And I put it on 2 Pis so I can reboot the one. Because Jared Bader once told me that you should treat your servers like cattle and not like pets. And then another setup that I have is I have 2 different hypervisors in the same rack. I'm running DNS recursors there, and I have 4 nodes in that particular setup. I actually redid this whole setup as part of this talk, which was good because it was decaying from being ignored for too long. So, and I ran into some new issues to talk about, which was exciting. And then I have another setup that's not here in this city that has DNS recursors in 3 different sites. And that's all within one service provider network, but they're in different buildings. And in even different parts of like the power grid in that particular town, so. And of course I had to include the DNS haiku here. It's not DNS. There's no way it's DNS. It was DNS. And this has kind of informed the way that I've gone with the Anycast stuff. One of the things about DNS is that every single operating system handles it differently, and they handle failure differently. And so what happens if your primary DNS server goes away? Well, in some operating systems, it tries both immediately. Some operating systems, it takes 5 systems to fail, or 5 seconds to fail over. Some operating systems will try the dead first DNS server every single request before failing over to the other one. And so this this is an area where maybe if your DNS server is just up all the time, and I mean up all the time is always theoretical, but as high as the most available that it can be, and the most performant that it can be, then it'll just result in things working better. So some of the platform peculiarities that I've run into, there's a lot of weird gotchas on Linux actually. So don't run your servers, your Anycast servers in the same shared segment as your users of that, because ARP will mess with you. On Linux, there's not the concept of individual interfaces. An IP is attached to an interface. It's like a host with a whole bunch of things that just go in different directions, and you hope that the IPs and stuff talk on the right directions, but they don't always, and especially when it comes to binding extra addresses and things like that, it can be pretty crazy. One of the things I ran into was I rolled some fresh new Debian 13 systems and I used cloud in it, and man, it was really, really, really painful trying to bind a second loopback address. The first loopback address you could do it through, etc., and networking interfaces. Second one just didn't exist. So I had to learn how to use NetPlan for that, because I guess cloud in it forced me to do that. I had basically no issues with BSD. It was absolutely great. FreeBSD and OpenBSD are fabulous platforms to use for this. The MikroTik stuff, here we go. So when I was running the Radius test on this, I discovered that the Radius server that MikroTik provides, called User Manager, instead of replying with the address that you've made your request to, it will use the routing table to make an outbound packet. And so if you make a request to an Anycasted service address, you might get a response back from the Ethernet interface address that the default route goes out. And I mean, no operating system works with a response that comes back from a different IP, and that was a pretty interesting one to debug. I had to basically turn on some pretty extreme packet logging for that one. And that one caused me to stop doing Radius Anycasting and just go back to having 2 redundant Radius servers. That was a better direction to go. So DNS at my house. So as I mentioned, I run 100.64.100.64 as a DNS recursor. That's from the carrier grade NAT RFC. So it's IP space that's supposed to be reserved for service providers, so that if you get like a NAT on your public IP, that you don't get a conflict. But I just wanted something. I wanted the cool IP that wasn't really taking a cool IP from the internet, like just reusing 1.1.1.1 or something like that. So this one here is at least from a range that's not on the internet, and it's not in a documentation range, so I don't know, it should be good. I run a Pi 3 with a PoE hat, so I PoE power that one. The Pi 4 is just a standard one, and I've had various VMs participating. It's health checked, so basically the second that the DNS server stops responding, as soon as 3 requests fail, it automatically pulls the DNS, or it automatically pulls the BGP advertisement, which then stops traffic from being able to go to a dead server. I'm using ExaBGP for this, and it has really nice health check stuff built in for this. I have blog posts about this on my blog, and I'm going to post some new ones about the most recent things I discovered. And solid state things provide very quick recovery time when the power goes out. So as I mentioned, the VM's great, it's fast, but it can be like 5 or 10 or 15 minutes to boot up versus like a Pi 4 or a Pi 3 could boot up in the same amount of time as like a little router or something like that. So, and you can ask my wife, DNS generally works at my house, so it's not like a broken service. So when does this fail? And this is, of course, where all the interesting things are. So complete network outages, obviously, when everything's down, everything is still down. Network maintenances. So depending on how your Anycast nodes are connected to your routers, if all of your Anycast nodes are connected to a single router and you do maintenance on that single router, well, now you've just lost all your DNS, and this probably is not going to provide the level of redundancy that you thought it did. However, if you have, half your nodes connected to one router, half your nodes connected to another router and maybe another location, like the RFC suggests, then you can end up with pretty high uptime. And of course, the other thing about network maintenance is sometimes you end up doing maintenance on a router that's in between the actual user and the service. And so there's really nothing that can happen about that. Like, that's an outage. Major network upgrades. So if you do like a software update on your routing platform and that causes changes in your config, like maybe a microtick in between 6 and 7, there was some pretty major changes in the OSPF and the BGP stuff. It can cause your next hop addresses to become unavailable. You can end up with route dampening issues. And then one of the other things is that, and this is a little bit less obvious than like a complete failure, but long-running flows can be interrupted if your active node changes. And so where do you notice this most? Well, if you've ever used Cloudflare and their Cloudflare D SSH stuff, you'll notice that like you can't stay connected to SSH. Like you're on for like 30 seconds, 20 seconds, 5 minutes, 30 minutes, 30 seconds. It's just really frustrating. And part of this is because of the way that they manage their Anycast nodes. When the node here gets too busy, they pull it. So if you have an SSH session on that, it's gone. And so I noticed that one a lot, unfortunately. Haven't noticed that same problem on LinkedIn, though. LinkedIn apparently runs all their stuff on an Anycast node, and I haven't noticed page failures nearly as often on their stuff. So conclusions. So this has been a really great side quest to go on. I've been using this stuff for over 6 years, and it's been really, really, really solid. Other than the few issues that I've mentioned with like network upgrades and things like that. So does anybody have any questions?